And here's a walkthrough for our building compounds. So I'm going to do it on paper so we can think through it a little bit better. I want to be able to show you guys the periodic table. So this will give you kind of the walkthrough that you can go back and take a look at your slides. It should translate fairly easily back to the slides. So we have our little broken down little mini periodic table that we've been working with. Right, it has the charges, it has the gaining or losing of electrons, and just some simple, very common elements that we're going to work with. So the first one that we see on the slides is NaO, so sodium and oxygen. And our job is to balance this compound as to sort of figure out how many sodiums and how many oxygens we're going to need. Okay, and it has everything to do with the charge. So first we need to recognize what the charge of sodium is going to be. So let me just get a different color here. Sodium, right? This is choosing the right bank here. So sodium is in group 1. So sodium is looking to lose 1 electron to become stable like the noble gases, right? It wants to have that complete valence shell. Right? It has 1 extra right now. If it loses 1, it'll just have 1, it'll have a full valence shell, stable, happy, right on. Okay, so sodium is plus 1, right? It loses 1 electron. If you lose something bad, that's good. Okay, you gain a charge. Okay, oxygen, on the other hand, on this side, it's actually going to gain electrons to become stable like the noble gases in group 18. So it's going to gain 1, 2 electrons. So oxygen is actually going to be -2, right? You gain 2 negatives, you become 2 negative. Okay, so this is what we're going to use to try to balance, right? On the left-hand side, we can put our sodium. Right-hand side, we have our oxygen. Okay, we're going to start to notice that this is -2. This is +1. It's not balanced. Okay, 2 and 1. What we need to do is add the sodium. Now we're +2, -2, balanced. Okay, and this is where I think some people are having trouble. Now we have to transfer, we have to change kind of mindset from this charge now to the amount of each. Okay, so our charge is balanced, right? +2, -2. But now I have to think about how many of each we need. We have 1, 2 sodiums, and we only have 1 oxygen. So we actually don't need to write this. It is. Okay, so this is what it should look like, right? You bring these down from the bank, and we should have 2 sodiums, 1 oxygen, so that it's balanced. Okay, balance our charges. Okay. Magnesium and chlorine. Okay, same idea here. Let's take a look at magnesium. Magnesium is in group 2. It's going to lose 1, 2 electrons to become stable like a noble gas. So Mg is going to be 2 plus. Okay, chlorine. Chlorine's in group 17. So close to group 18, it only needs to gain 1 electron, and then it'll be right there. So Cl wants to gain 1 electron, become 1 negative. Okay, so we have our charges. I'll put on the balance beam. So we have Mg2 plus and Cl1 minus. Okay, because these aren't balanced, right? We have 2 plus, 1 minus to get these to balance out to 0. So all we need to do is add another chlorine. Okay, now we can see that our charge is 2 plus on this side, 2 negative on this side, balanced. Now we need to change our mindset from the charge to the amount of each. So now we have 1 magnesium. Okay, 1. We don't need to write it. We can assume 1. We need 2 chlorines in order for this to be balanced. Okay. So then I didn't give you guys a balance beam, but I would encourage you to do it if it's working for you. I've given you a table. This is just another way to kind of organize your thinking. And when we start talking about the more difficult or complex elements in the middle of the periodic table, those transition metals, this really starts to come in handy. So we have lithium, and we have sulfur, and we need to figure out the charges. So here again, you can start to notice this pattern. Lithium and sodium, both in group 1, they both need to lose 1 electron. So just like sodium, lithium is going to be plus 1, right? You lose an electron, you gain a charge. Sulfur, on the other hand, okay, is 2 away from the noble gases, so it has to gain 2 electrons to become stable. Okay, so gain 2 electrons, you're going to be minus 2. Okay, notice that I've just been a little bit inconsistent between plus 2 plus 1 minus. It doesn't matter if you put the plus sign before or after. You just need to indicate the charge. So our job here now is we don't have a balance beam, but we are able to think about the charge. So we said the charge is plus 1. The charge here is minus 2. Okay, so how do we balance out plus 1 and minus 2? How do we make that equal to 0? How many of each do we need? Okay. One thing that I haven't talked about yet, but I think is a great thing about it, is lowest common multiple. Okay. So what's the smallest thing that both of these get to? Okay. 1 and 2, they both go into 2, right? They both go into 4, they both go into 6, but 2 is the lowest. Okay. So how do we get to 2? We need 2 of these and 1 of these, and we'll see that the total charge is going to balance out. Okay. Another thing you're going to notice is that these switch, right? And this is going to be generally the case. We just have to make sure that it's in lowest terms, just like reverse suppression. But we haven't seen that yet. Okay. So now we've been talking about the charge and the amount in this table. We need to pull out the right information. We have the amount right here. So we need 2 lithiums and 1 sulfur to make this work. Okay, so now it's balanced. Okay, beryllium and oxygen. Okay, same again with this table here. We have the charge, we have the amount, and we have total charge. Okay, so we have to think about the charge on beryllium. Okay, beryllium is in group 2. It has to lose 2 electrons to become stable like the noble gases. Again, we get to that full valence shell. So it's going to be 2 plus. Okay, oxygen is 2 away from the noble gases. It has to gain 2 electrons. It's going to be 2 negative. So beryllium is 2 plus, oxygen is 2 negative. So you can see that these are already balanced out, right? We have 2 positive, 2 negative. They're balanced out to get to 0. Okay? So we actually only need 1 of each of these. And this is where that kind of cross, we have to make sure that it's in lowest common terms. Okay, so the charge here, the total charge 2 minus 2 plus, need 1 of each. Right, this is the amount. We need 1 of each, so we don't need to write it in. Okay, next one. Sodium and nitrogen. Okay, so I'll just put the charge the amount and the total charge. Okay. So sodium. Sodium we should be familiar with. Okay, so in group 1, it needs to lose 1 electron. It's going to gain 1 charge. Nitrogen. Nitrogen now is 3 away from the noble gases, so it needs to gain 1, 2, 3 electrons to become stable and fill up its valence shell. So it's actually going to become 3 negative. Okay, so our charges are +1, -3. Okay, if we need, we can still use a balance beam, right? And in doubt, use what you know. Use what works. Okay, so we have Na +1. We have nitrogen -3. Okay, we can see these aren't balanced. What we need to do is add more sodium. Okay, now we have 1, 2, 3. So we have +3, -3. They're balanced good. Okay, we can also see that this cross is going to work, right? We need to balance out these 3 negatives. We're going to need these 3 groups of positive. We're going to need 1 group of the negative. Okay, so we're going to need 3 sodiums, 1 nitrogen. Okay, if we have 3 groups of 1, we're at +3. If we have 1 group of -3, we're at -3. We are balanced. That's looking good. Now we can take our 2 amounts and transplant them over here, right? We need 1 nitrogen. We don't need to write that. Okay, we can assume. Okay, so hopefully you can see where you made your mistakes. If you still have questions, please message me on Hangouts, and we can work through it. The biggest thing here is being able to transfer from thinking about the charges and then thinking about the amount of each, right? That's the big step. Let me know if you have any questions. Okay. Look to see you guys. Cheers.